Hello guys, today we'll be learning about doubly linked lists, which are an integral part of your data structures and algorithms. So a doubly linked list is just that, a list which is linked with each other, but what makes it doubly is the fact that it can reference the previous address and the next address at the same time. So if you don't understand these terms, I'm going to simplify them for you by using this diagram. So here we have the head, which is going to be the first node. Think of it like a train box. Is that what they call it? Box compartment. So think of it as a train compartment. Here we have three components: the previous address, the next address, and the content itself. You can name each node anything that you want. So, but just for the sake of simplicity, we are going to name this head, first, and second. Here we have three nodes. So they contain the values of 1, 2, and 3. The head contains the 1. It also contains the previous address and the next address. So here the green lines indicate a front traversal and the blue lines indicate the back traversals. Okay. So in this, as you can see, it has a previous and a next address. So what it does is it stores the previous address and the next address at the same time. This way the front and the rear traversals are both possible in a doubly linked list, which is the reason why it is a doubly linked list in the first place. See, in a singly linked list, all that would have happened is that only frontal traversal would have been possible, as in it only stores the next address and not the previous address. This way it can go like this, and it can also go like this. So that's basically it. The previous address for nodes that don't exist and the next address for the last node doesn't exist, which is the reason why we'll be storing it as null. Technically you don't have to put it like that, but I guess it is good practice to put it in the code itself. So now that you understand how a doubly linked list works, we are going to move on to its code. So in this we have made a class named node. This is where we are going to perform majority of our nodal work. It has an int value which is going to store the value in integer format. It has two nodes named previous and next. Okay, the previous is what making this node is what makes it a doubly linked list. We are going to use this to make sure that we don't mess up the code for the doubly linked list. Next up we have this function, which we are going to ignore for now because the main part is in int main. Here we will be making the three nodes as shown to you in this diagram: head, first, and second. We are going to name this head, first, and second. Technically I named it fist, but who cares, bro. We are going now what we are going to do is we are going to assign its values okay, and then we are going to make sure that the head references the previous and the next node. Considering that the head does not have a previous node, it is going to store it as well as shown in this diagram, null. And just like that we have second, which is not going to reference any other node, so that is going to store exactly that, null. This way we have basically made a doubly linked list. Now the thing is that we have to print this, so we have made a function called printing, which is of void format, void type. Okay, this is going to take the argument of head. Now head is obviously a node, so we are going to pass this as node n. Okay, then we have a cout line, which is just for beautifying things. Then we have a while loop, which is going to be up until n is not equal to null, this part is going to run. Okay, and that's pretty easy for it to encounter. We have a null here, it's going to run till that. Then we have a cout, which is just going to print the value of the first node, which is the head node. Okay, and then it is going to go into this if statement. If the next node is not null, then you're going to print this. Basically, this arrow, I'm going to remove this, considering we have to acknowledge this function right now. Now we are going to print this. This is an arrow which has another arrow going in the same direction. Okay, it shows that we can interchange things now. Not exactly interchange, but traverse things in both ways possibly. Next up, when we are done with this, it is just going to increment this. Okay, that's all this is. This is just a way of incrementing. Okay, this is going to send the next in. This is going to send the first. Okay, now it is going to now go back into the while loop. It's going to check if this first is equal to null. Well, it is not, so this is x. So the same process is going to run now up until we have this. Okay, now this line is going to print at the end. Once we are done with this, when this gets encountered as a null, this if statement is not going to run. So what is going to happen is this, it is going to print null. Okay, we seem to have a problem over here. Let's see what happens. Oh, it's missing something. Very nice, bro. Very nice trying to teach people. Functional definition is not allowed. Bro, what is going on, bro? Okay, I understand now. I just messed this up. I want to run this again and see it runs again. I accidentally ended up deleting this. So here you can see that this is the output. Okay, it starts off as null, so this is just going to print out every time that we call this function, right? We're going to print it as null, and then it is going to go to the head node. Okay, so this is exactly this is the first part which is going to get couted. Basically it means that it's going to get printed. This is the first thing which is going to be printed right here, right now. After that it goes into the while statements. Okay, here it is going to check if head is equal to null, which it is not. Okay, so this is going to print 1. Then we have first, then it is going to go up ahead, increment 1 time, and then it is going to go to first, considering that we are done with head. Next address refers to the first one now. When the first one is done, it is going to refer to the second node. When the second node is done, it is going to go to this null, meaning that the last node of any linked list, doubly linked list to be precise, stores only null. Okay, that's the only thing it can store possibly. The next address, technically you do have circular linked list, that's out of syllabus for this video. And that's pretty much it for this video. I hope you understood this. Pardon my English. You could take a screenshot of this if you want to, or else don't worry too much about it. You're going to fail your exams anyway. As for the code, I'll copy paste it in the comments or pinned comment or in the video description. Okay guys, see you later.